Here we go. The Zoom session is being brought to you by the Fractal Swirly 3 Horizon S. Okay. All right, for today, the end of the book. Two last sections, hyperbolas and 7-4. Oh, shifting tonics. All right, hyperbolas. All right, is this kind of double U shape. You've seen them actually, believe it or not. Start with a lampshade in the room up against the wall. This is the shadow the lampshade casts against the wall. That's one way of looking at it. A hyperbola is another way to look at it. Is you start with 2 points, F1 and F2, called the foci, and the hyperbola is a set of points P such the difference between PF and PF2 is a constant. One branch, F2 is closer. The other branch, F1 is closer. And the difference, the absolute value of the difference, is a fixed constant, and that's a hyperbola. There will be 2 lines called the asymptotes that the hyperbola approaches. All right, here's a classic one. X squared over a squared minus y squared over b squared equals 1. That's a graph of a hyperbola. It will have vertices plus or minus a by 0. And you draw a box, and this box has horizontal lines at plus or minus 0 by plus or minus b. And with this, from this box, you draw these 2 diagonals, and those are the asymptotes. And the 2 foci are here at plus or minus c by 0, where c is the square root of a squared plus b squared. And the asymptotes are y equals b over ax and minus b over ax, like that. Now there's what's called, this distance here is called the horizontal transverse axis. Its length is 2a. Now we could swap these 2 terms. Y squared over a squared minus x squared over b squared equals 1. Now again, the vertices at plus or minus a, it's 0 by plus or minus a here, where it's going up and down the y-axis. Go at plus or minus b by 0 here and make this box. Draw the diagonals, and those are the asymptotes, which are plus or minus a over b times x. The vertices at 0 plus or minus a. The foci at 0 plus or minus c, where c is, as before, square root of a squared plus b squared. Like that. All right. And here, this is the length between the 2 vertices is in this case the vertical transverse axis. Length is twice a. So, for example, find vertices, foci, asymptotes, and graph of y squared over 36 minus x squared over 4 equals 1. Right, 36 is 6 squared, 4 is 2 squared, y squared over 6 squared minus x squared over 2 squared equals 1. So, because y is going first, we put these vertices on the y-axis. Just a second. Good check. And so here's a point 0 by -6, 0 by 6. Those are the vertices. Go to plus or minus 2 by 0. Make this box. Draw these asymptotes. And those are the asymptotes. And excuse me. And then the hyperbola is asymptotic to those asymptotes, looping around, touching the vertices, loop around these foci at 0 by plus or minus c, where c is root 6 squared plus 2 squared. That's root 40, which is about 6.324. So the foci are plus or minus 0 by plus or minus root 40. And the asymptotes, 6 over 2 is 3. So this is y equals 3x and y equals minus 3x. All right, here we have x squared over 4 minus y squared over 16 equals 1. Find the usual vertices, foci, asymptotes, and graph. Okay, 4, write that as 2 squared. 16, write that as 4 squared. So the vertices are on the x-axis, the leading term, and they're plus or minus 2 by 0 here and here. We draw the central box by drawing going up and down to plus or minus 4. Draw this box. Draw these 2 lines. They're the asymptotes. The hyperbola comes in along the asymptotes, go through this vertex and away, asymptote, vertex, and away. The foci, well, it's plus or minus c by 0, and c is root of 4 plus 16. That's root 20. That's about 4.4. So here and here. You can see that I mistakenly put foci here and here. My mistake. So here it is. This is the graph. All right, now let's run it the other way around. We're given foci at 0 plus or minus 2, vertices at 0 plus or minus 1. Okay, the foci are on the y-axis, so it opens upwards along and downwards along the y-axis. So y squared term is 1, and the vertex is at plus or minus 1. So it's y squared over 1 squared minus x squared over something squared equals 1. We don't know what that b is yet. But we know that the foci are at plus or minus 2. So c is 2. C is 1 squared plus b squared. That's 2 squared equals 1 squared plus b squared. So 4 equals 1 plus b squared, 3 equals b squared, b equals root 3. So put the 3 here. Y squared over 1 squared minus x squared over root 3 squared equals 1. Or equivalently, y squared over 1 minus x squared over 3 equals 1. That's the equation of the hyperbola. Now, let's start trying with this. We have foci at plus or minus 5 by 0, and the length of the transverse axis is 6. The foci are on the x-axis, so it goes left and right. The x squared term is first. The transverse axis has length 6, so distance to the vertices is half of that, which is 3. So the vertices are at plus or minus 3 by 0. Okay, so now we know it's x squared over 3 squared minus y squared over something squared equals 1. This something is b. What is b? Well, c squared is a squared plus b squared, and we now know that c equals 5. 5 squared equals 3 squared plus b squared. So after a little bit of work, 25 equals 16 plus b. Oh my goodness. This is a mistake. I get honked. Oh dear, dear, dear me, dear me. This should be b squared equals 9, 25 minus 16. So b is 3, not 4. My mistake. I definitely erred on that one. This is page 7. B equals 3. Okay, that was a blunder. So it should be a 3 here. Hold on, is that right? Oh, for goodness sakes. No. This should be a 9. And this will be a 16, and this will be a 4. 25 equals 9 plus b squared. My error. So I'll have to change this in the canvas. My apologies. So, but this, okay, so this is still valid. Well, x squared over 3 squared minus y squared over 4 squared equals 1, or in other words, x squared over 9 minus y squared over 16 equals 1, and that does the job. Okay. All right. So I have a definite change to be making. All right, then. Okay, that concludes that part.